Hello there, Mr. Sutton here with the IM376 Extra Practice number 2 solutions on law of sines. For this problem, I'm trying to find this missing side. Now this triangle is not necessarily a right triangle. In fact, you could add this up and see that this is not going to be 90 degrees, but we do have a side and an angle across from each other that we know both of them. So we can use law of sines on this one. Sine of A over A equals sine of B over B. So let's start with the side angle pair that we know the most about. We've got sine of 59.9 degrees over the opposite side from that, 25, equaling sine of my other angle, 56.1 degrees, over its opposite side, which is the x that we're looking for. Now to get x by itself, we need to cross multiply and then divide by the sine of 59.9. So we got this 25 needs to move up here with the sine of 56.1. X needs to move over here with sine of 59.9, but then we need to immediately divide by sine of 59.9 and bring it down here. So let's just plug all this in the calculator as is. So plugging all that in with alpha y equals for my Francie fraction, we press enter and get 23.98, so 24.0 if we round off. And we know that's the only answer because this was a side, not an angle we were looking for with law of sines. To find this missing angle here, we have to first recognize that this is not necessarily a right triangle, but that we do have an angle and a side across from each other. So that means we can use the law of sines. Sine of A over A equals sine of B over B. Let's start with the side angle pair that we have actual numbers for. So we've got sine of 20 degrees over 21, the side opposite from it, equals sine of, well, we don't know this angle, so we'll call it x, over the opposite side from that, which is 35. Isolating sine of x, we just multiply by 35, so that's 35 sine of 20 over 21. And then to actually get x by itself, we have to take sine inverse of this huge fraction over here, so let's do that on the calculator. So here I am on the calculator. I set this up by doing second sine to get sine inverse, and then I did alpha y equals for my Francie fraction here. Pressing enter on all that, we get 34.8 degrees, if I round that off to the nearest tenth. Now, this is definitely one of the correct answers. We don't know if it's the only correct answer or not. To figure that out, we need to look at the alternate answer by subtracting this from 180. And let's see here. Let me just do that on the calculator. So 180 minus 34.8, that gives us another possibility of 145.2 degrees. Now, this might be a good answer or it might not. To figure that out, I have to see if it actually fits in the triangle with this angle up here that they already gave me. So 145.2 plus this 20 degrees, is that less than 180? It is. It's 165 and some change. Since that is less than 180, we have proven that it is a correct answer. So both of these answers, 34.8 and 145.2, are good answers. On this one, we're trying to find a missing side in this triangle. Now we can take a quick look here and realize that this is not a right triangle. However, we do have an angle and a side across from each other that we know. So this is a good one for law of sines. Sine of A over A equals sine of B over B. So starting with the angle side pair that we have numbers for, we can write sine of 67 degrees over 16 equals sine of the other angle, 78 degrees, over its opposite side, which happens to be the x we're looking for. Now to solve for x, we have to do some cross multiplying. So I've got 16 times sine of 78, and then I've got an x times the sine of 67, but I'm going to have to divide by sine of 67. So that's going to move down here. So just plugging all this into the calculator, let's see what we get. So here on my calculator, I did alpha y equals to get my n over d Francie fraction, and I've got 16 sine 78 over sine of 67. Press enter on all that. We get 17.0 for that side. Now, since this is a side that we found with the law of sines rather than an angle, there's no ambiguity. We know that this is the one and only answer, and we are done. On this problem, I'm trying to find this missing side. Now, since this is not a right triangle, I mean, we know this for sure because we've already used up 102 degrees. We don't even have 90 degrees left over anywhere. Since it's not a right triangle, but we do have the angle and the side that are across from each other, at least one such pair, we can use law of sines. So law of sines is going to be sine of A over A equals sine of B over B. So let's start with the angle side pair that we know both numbers for. sine of 45.6 degrees over the opposite side from that, 12, equals, now we do sine of the other angle we know, sine of 102, and the side that's across from it, this x right here. Now to get x by itself, we have to cross multiply. So we've got 12 times sine of 102, and then we'll have x times sine of 45.6, but I'll divide by sine of 45.6, so that ends up moving it down in the denominator, below the 12 and the sine of 102. Let's just plug all this in the calculator now and see what happens. So here I am on the calculator. I used alpha y equals to get my fancy fraction, and then pressing enter on all that stuff, we end up with 16.4. So that's this missing side down here, which it makes sense that it's bigger than 12 because 102 is bigger than 45.6 degrees. And we also know that this is the only answer. We don't have to find an alternate answer because this is a side, not an angle. So law of sines is not ambiguous on sides. On this one, trying to find an angle, and I'm not sure whether or not this is a right triangle. It's possible that it is if this other angle is 45 maybe and this one's 90. I mean, who knows? But what I do know is that I have an angle and a side across from each other that are known. So that means I can use the law of sines. Sine of A over A equals sine of B over B. Let's start with the angle side pair that we actually know everything about. Sine of 45 degrees over 17. And we're going to set that equal to sine of x, the angle that we don't know, over the side across from that, which is the 28. Let's isolate sine of x. I can do that by multiplying by 28. So we have 28 sine of 45 over 17. And now I just have to plug this into the calculator. Although, actually, let me back up for a sec. Just plugging this in the calculator will just give us the sine of x. To actually find x itself, we actually need to take the inverse sine of all this stuff. But we still need the calculator for that. So let's try this again. So here's what I've got on the calculator. I did second sine to get sine inverse here because I need to get rid of sine. And then I plugged in all of this stuff using alpha y equals for my fancy fraction. Pressing enter now, we get an error. Now, assuming that I entered this stuff correctly, that means that the x here is actually undefined. And that's happening because this triangle doesn't actually exist. Although they drew a triangle, it wasn't necessarily drawn to scale, and it didn't even necessarily exist. Since this is not a real triangle based off the dimensions they gave us that broke the law of sines, that means there is no solution to this particular problem. On this problem, we're trying to figure out a missing angle. Now, this is definitely not a right triangle. You've already used up over 90 degrees with just one angle. However, we do have the side across from that one angle, which means we can use law of sines since we have an angle side pair. So we have sine of A over A equals sine of B over B. And now plugging things in, let me start with the angle side pair that I know. So sine of 111 over 35.5 equals sine of the other pair there, so sine of x over the other side that's across from it, so 11. Now let me get sine of x by itself. I can do that by just multiplying 11 over here. So I've got 11 sine of 111 degrees over 35.5, and that all equals sine of x, not x itself. To get x itself, we have to take sine inverse of both sides. So let me do that on the calculator. So here we are. I did second sine to get sine inverse, and I did alpha y equals to get my fancy fraction. Plug in that in and press and enter. We get 16.8 degrees. So we do have at least one answer that works here, 16.8 degrees, but we might have an alternate answer as well if we subtract this from 180. So let's see what that alternate answer would be. Now let's see here. 180 minus 17 would be 163, so this is going to be 163.2. And will that fit in the same triangle with the 111 that they gave me? Well, if I do 163.2 plus 111, I'm not sure off the top of my head what this comes out to, but it's definitely way more than 180. Since that's more than 180 degrees, it will not actually fit in the same triangle. So that means 163.2 is a bogus answer, and the only true answer, the only correct answer is the 16.8.